Good morning, everyone, and thanks for coming to my talk, and thanks for the introductions. So my name is Robert. I'm a software engineer at Google, and together with my team, we've been working on Service Weaver, an open source framework for writing distributed applications. How many of you heard about Service Weaver? Okay, so it will be new for most of you guys. I guess let's start the talk. How many of you are using microservices to write your applications? Okay, great. So yeah, microservice-based architectures have become extremely popular, and all of you guys are writing microservice-based applications. And if you look at this Google trend graph, the interest over microservices just increased over time. And we as a community also, we've developed a lot of technologies that help to grow the microservices ecosystem. For example, we did Docker and Kubernetes for easy and flexible deployments, service meshes like Istio for interconnecting microservices, CI/CD pipelines like Argo, Jenkins, telemetry frameworks, OpenTelemetry, Prometheus, and so on and so forth. So there is no doubt that microservices are popular and widely useful. But the question if they are universally great for everybody is still there. To make things even more confusing, if you look at the trends driven by the big companies, you see mixed signals as well. So for example, there is a strong debate, the question whether microservices are still universally great is still there. So if you look on the internet, YouTube videos, Twitter, wherever, you see people have very contradictory and opinionated views on microservices versus like monolithic-based architectures. So for example, here we took a random Reddit post and look at some of the comments and see what people think about microservices and versus monolithic architectures. So for example, someone is saying although most people think a microservice architecture is a panacea, it's not that simple because in the end it's a distributed system and doing distributed systems is challenging. Another person believes that microservices are great, it's just we are doing it the wrong way because we don't know how to draw the boundaries correctly. While another person just loves microservices because they hate monoliths. Another person believes that microservices aren't bad, and when people say they are bad, they just don't understand how to use them and when to use them. And another person actually can't even tell if their project is a monolith or microservices, and so on. So to make things even more confusing, if you look at the trends in the big companies, there is also mixed signals. So for example, companies like Uber, Etsy, eBay, and AWS argue that microservice-based architectures are great, and over the years they migrated their monolithic stacks to a microservice-based architecture. However, in the spring this year, Amazon Prime published a blog post where by switching back from microservices to a monolith, they managed to reduce the cost by 90%. So we believe there are three fundamental reasons why writing microservice-based applications is challenging. First, there is no official guidance on how to write your application. Should you start with a monolith where you write everything in a single binary and then keep the monolith as long as possible and split later when you know what to do? Or maybe start with a microservice-based architecture and split as much as you can, because once you deploy your application, it's extremely hard to change anything. Second, we don't live in a clear black and white world where neither microservices nor monoliths are good or bad. It's all about trade-offs. So they live in a vast trade-off space where we have to trade off things like ease of development, ease of deployment, ease of testing, observability, performance, and so on and so forth. And finally, frankly speaking, the whole ecosystem is complicated. Clouds are complex. We have lots of technologies to learn how to deal with the cloud. And once we get used to some of these technologies, another one is being released, which claims that it's even better, right? Also, often when we design our applications, we don't do it just based on technical reasons, but also based on bias. So for example, we look at trends in industry, and if you see like, big companies like, Amazon and Uber and Etsy and whatever, they are using microservices, we believe that microservices, is a way to go, and we should write microservice-based application, even if we don't understand, which decisions led to them to use microservices and whether their use case applies to us as well. And finally, maybe we try to use some frameworks, some programming frameworks in the past, but then we had some bad experiences, and then we believe that all of them have some fundamental problems, even if they can help solve some of the challenges we have when writing applications. So we came up, based on our experience in writing applications in Google, and also what we've seen in general in the community, we came up with 3 ideas on how to address these challenges. First, we believe that you should write the application as a modular binary, but deploy it as a set of microservices. In other words, by separating the logical and the physical boundaries, it allows you to change the physical topology of your application on the fly and easy. Second, we believe that you should delay these decisions of whether you should do a monolith or a microservice-based decisions for later as much as possible, hence to minimize the need for trade-offs. So for example, right now, when you start designing your application, you have to think, oh my God, should I start with a monolith? Should I start with microservice-based architecture? Which of these trade-offs are important to me? And it's extremely, extremely hard and challenging to reason about, especially that you don't understand your use case so well. So we believe start writing a monolith application and start splitting your applications into microservices only when you understand, only when you have enough experience with your application and understand all these trade-offs and which things are important to you. And last but not least important, we believe that you as a developer, you should focus on the application business logic and offload all these complexities of cloud interactions to the runtime. We believe that we can be more opinionated on which underlying technologies to use to run your application than the developer who has to understand all these trade-offs and all these complicated challenges. So we have these 3 ideas, but what do we do with them? So basically, we took them and we implemented them in a framework called Service Weaver, which is a framework for writing better microservice applications. And for now, it's just Go. Our goal is to make it easier to develop, deploy, and maintain high-performance applications with multi-cloud support and which significantly reduce your cloud costs. So let's go a little bit into more detail. What is Service Weaver? So in terms of development, you organize your code as a logical monolith, where you write your services, as you'll see, Go interfaces in the same application binary, using only native language programming features, and you have no code versioning concerns. Once you write a single application binary and a tiny config, the Service Weaver runtime will strip your binary into a set of connected microservices which run at the same versions. And then you can run this binary without any changes, both locally on your laptop, in a single process, multi-process, in a Kubernetes environment, on a set of VMs, or in Google Cloud and whatever. The Service Weaver runtime has a bunch of optimizations which help to reduce the latency and also improve the reduce the cloud costs. And finally, we have, we provide tools to give you easily metrics, logs, traces, and to make it easy to test. So let's go a little bit into more details into what is the experience for a developer to write a Service Weaver application. So an application consists of a set of components that call each other, where a component it's very similar to an actor, for those familiar with actor-based model. Under the hood, Weaver has a code generator to weavify the application. For example, we generate encoding, stubs, registration, and so on and so forth. So you write the application as a bunch, as a modular binary, where here, for example, define your services, rock, paper, scissor, as just Go structs. And then you can deploy it locally in a single process or in multiple processes. And then same application binary, you can run it distributed. Like components being replicated, collocated, traffic load balanced, and so on. So let's see how to define a component. A component is literally a Go interface. So in this case, let's say we want to declare like a cache component with a put method. And of course, you can define a get method as well. To do that with Weaver, the only thing we have to do is when you implement this interface, you have to add this weaver.implements embedding, which tells the Weaver runtime that this is a service Weaver component and has to be handled accordingly. Now, how to instantiate and run a service Weaver application. So as I mentioned before, a service Weaver application consists of a set of components. And among all these components, one of them should be the main component, which is the entry into your program. To define a main component, again, you define a Go struct, and you have to add the same embedding, weaver.implements, except that you have to say weaver.main. So now this app component basically is the main component. Then if you want to reference a component from a different component, you can use this weaver.ref. So in this case, in the main component, we can get a reference to the cache component. And now we have a main component, we have your cache component. To run this program, you can use weaver.run, which takes like a lambda, which takes always like the main component, which is the entries in the program. And to interact with components, you simply do method calls. In this case, you just do cache.put. Note that these methods, in this case put, can be executed both locally in the same process or remotely. So that's why in Weaver, every single method which has to be exposed by a component has to return an error. And of course, has to be handled by the user in the code. All right, so now that you saw how to write a service Weaver application, how to deploy this application. So as I mentioned before, you release a single binary, and you write a single config. Actually, to run it locally, just do go run, as simply as you run today. If you want to run it in a multi-process environment, you can use our Weaver multi-deployer, and you just use Weaver multi-deploy, where you just specify the name of the binary in this toml config, and you run the same application, but each component in a separate OS process. Now, if you want to run, of course, the same application binary distributed on a bunch of machines, then you have to add per deployment config. So in case you want to run it on multiple machines or VMs, you can use our Weaver SSH deployer, where you can just specify the locations of these machines, which are reachable via SSH. And then you just do Weaver SSH deploy. Same application binary now runs on a bunch of machines. Or you can use our GKE deployer, where you can specify the regions where you want to run your application and which listener, which address your application should be available at. And then you can do Weaver GKE deploy. And that's it. And this is an extremely powerful deployer because it allows you to roll out your application across multiple regions. We do blue-green deployments, we do routing, we do custom resource management, we do a bunch of stuff. However, if you don't want to run in the Google Cloud, and we have so little control, then you can use our Weaver Kube deployer, which allows you to run on any managed Kubernetes cloud. To run the Kube deployer, which I will show you a little demo today, you have to write this little YAML config, where you specify the app config, for example, the repository, where your Docker image has to be uploaded, and then for your listeners, which I will touch in the demo, which is basically a way to interact with your application, whether they have to be you want them to be public or reachable outside of your cluster or not. And of course, in your YAML config, if you want more control on your application, you can specify resource requirements, you can specify scaling specifications, you can specify volumes, probes. Basically, we look at the Go survey, identify the top knobs people say they are configuring in Kubernetes, and we expose them for you. Yeah. So basically, you can specify these kind of things as well. But then you can run this weaver kube deploy command, which basically generates all the Kubernetes information to run your service weaver application in the cloud. And then you can simply do kubectl apply and run it, or you can integrate with GitHub Actions, whatever CI/CD pipelines you want to. The nice thing about this deployer is also very customizable. So you can export observability data to your favorite framework, or works with your favorite CI/CD pipeline and others. However, even if this deployer you are not happy or you don't like it, you can write your own deployer. And here we have a nice blog post which tells you how to write your own deployer. So let's go a little bit into more details how the service weaver application actually is being deployed. So as I mentioned before, you write a single application binary where you put all your components in a single binary. But then the Weaver runtime will place these components into different processes. However, the user, I didn't specify here, but in the config, has an option to collocate some of these processes, for example, for performance reasons. So in this case, the user can collocate rock and paper together. So if they communicate with each other, they will just communicate through direct method calls and bypass the network. Now, the Weaver runtime will attach these Weaver libraries, which manage the interaction between the application and the runtime. And finally, the Weaver runtime will run your application. And as I shown you before, you can have different implementations. Same application binary, you can run it locally, multiple machines, GKE, Kubernetes, and so on. So let's briefly talk about performance. So the service Weaver runtime has a bunch of stuff to make your application highly performant. So for example, we have an efficient encoding, decoding mechanism with no versioning overheads. We have our own custom transport built on top of TCP with custom load balancing. We provide this collocation or flexibility to collocate some of these components in the same OS process for performance or isolation and so on. And also we provide routing, which increases the likelihood to route requests to the same key to the same component replica, basically enabling you to write stateful applications. And yeah, we did some benchmarking, and actually we keep doing benchmarking, and soon we'll publish some new blog posts with new performance numbers. But we took the online boutique applications. It's a very popular application advertised by the GKE Fox. The application has 11 microservices, and for a fair comparison, we converted all these microservices to Go. We tested on GKE in a region using that throughput and yeah, E2 medium VMs. And we tested the microservices version, which is the default version, versus the Weaver version of the app. And we look at a few metrics. So here we looked at the number of lines of Go code and the config code you write with Weaver versus Online Boutique. So with Weaver, you definitely write less code because you don't have to write all this boilerplate about registration, defining protos, setting up HTTP servers, and so on. The difference is not that huge for this application. We took another one, Bank of Antos, actually more recently, and the decrease is actually 40%. In terms of config code, there is no comparison because to run microservice version of the app, you have to write all these YAML files. And I think in this case, it was like 1,500 lines of YAML files for the microservice version of the Online Boutique. While with Weaver, it's like you write 3-4 lines of config. We also look at performance. Here we look at how many CPUs for this particular workload we use when you run with Weaver versus the microservice version of the app, and also the 99% latency. And yeah, the number speaks for themselves. And this is mostly because of all the optimizations we do in our runtime. Telemetry and testing, I'll quickly mention. So we provide, every component in Weaver comes with an associated logger, which is basically a wrapper around slog, which you guys will hear later today from Jonathan Amsterdam. So yeah, having a component, you just do component.logger, and yeah, you can log your stuff. And also we provide different ways to manipulate your logs. For metrics, we have our own package, and we provide counters, gauges, and histograms. And also we auto-generate some of these metrics for you. For example, to track the latency between these applications, the throughput between components, the throughput between components, and so on. Tracing, we rely on OpenTelemetry, and once enabled, all your HTTP requests and component method calls are automatically traced, and basically you just have to write a single line to enable tracing in all your application. And of course, we do profiling as well, which capture the performance of your application as a whole. So I know this was quick and very high level. Let me do a quick demo and write a simple app and get a better experience how Weaver looks like. So let me go here. And yeah, so let's write, I don't know, can you guys see this, or is it too small? Do I? Okay. So let's write a simple, hello world application for now, and then we'll evolve it a little bit more. Okay, this is very small here. How do I increase that one? Zoom in. Oh, let me see if I can do this.
Use the gesture.
Hmm?
If you go here and use the gesture. No, the zoom in gesture. On the touchpad, the pinch.
Oh, like that. This is a Linux machine. It's in my Linux machine. Yeah. Okay. Is it too small? No? Okay, so let's write a simple Hello World application for now with Weaver. So as I mentioned before, we have every service Weaver application has a main component. And let's just implement that. And to tell Weaver which one is the main component, we have to add this Weaver dot main embedding. And that's it. Now let's write a main, to run this application as well. So you do, just in your main function, you run this weaver.run, which takes a context and then takes this lambda. And this should contain a reference to the main component, in this case, app. And actually, let me put this in a different, no, let me put this in a different, okay. What's happening here? Okay. Seems like okay, I'll write it from scratch, it doesn't work. Yeah, so we'll take, I'll put that in a separate function. And yeah, this is basically the body which will execute with Weaver. So in this case, let's just print for now, hello world. And that's it. And then here, I know what's happening, but I will just type this. And yeah, we want to handle the error as well. So if the error is, we just panic for now. Okay. Okay, I think I'll move here. It's very hard to type there. So yeah, actually this is, oh, thank you. So this is a simple service viewer application. And now, as I mentioned before, we have to run this weaver generate. I don't know what is this. Oh, I think. The what? Oh yeah, thank you. That's the beauty of, live coding. People can point out my mistakes. Yeah, so if we do weaver generate, let's hope it works. And then if I do go run, here it is, hello world. So this is the basic application. Now let's add some functionality, and the functionality add is like, let's reverse a string. Given an input string, we can reverse the string. So let me add another component in this case called reverser. Okay, I type it wrong, and as I said, to define a component, you can define this Go interface and you define the methods. So in this case, let's add a reverse method, which takes the context and the string you want to revert, and we return the reverse string and an error. What is this? Oh, I think I'm still sleeping then. Okay, so we define, thank you. And then we write the implementation as a Go struct, and then again, weaver.implements reverser. We'll tell the weaver runtime this is the component, and then we add the implementation itself of this function. And yeah, we'll take the string and we'll just revert it. And for this one, I'm just going to copy the logic because I'm not going to type it now. But the logic is something like, nothing fancy. It's just split into these runes, and then we reverse them. It's nothing weaver specific. So this is it. This is the implementation. And now let's see how to call it. So in the main component, we can get the reference to the reverser by calling weaver.ref on the reverser. And then instead of printing hello world here, we want to reverse, let's say we want to reverse the hello world for now. So yeah, to do that is reversed, okay, yeah, reversed and error. Reverser.get.reverse, and then context, and let's say hello world. And then let's print the reverse string. And of course, let's be correct here. Yeah. Okay, so now because every time you add a new component, remove a component, add new methods, or you modify the signatures of these methods, you have to rerun weaver generate. Weaver generate, let me show you, generates this weaver _gen file, which is basically the code which the weaver runtime will run for you. And this is not something you as a developer should look into it, but this is, you see, basically what it's kind of the magic we do. How we create this like client and server stubs, how we register your components. We add, if you enable tracing, we add all these trace spans. We have this custom serialization, deserialization, like here, for example, when and yeah, we generate some metrics for you and so on. Anyways, okay, so let's start again now and run your application. Okay, so it works. Let's make the application a little bit more realistic. So let's add like an HTTP server, right? In practice, you want to write to reverse, let's say, multiple strings. So to do that, we have to export an endpoint on which we receive sorry, strings to reverse. So in this case, let's say on the endpoint reverse, we want to get the strings and return the results. And let me copy again what is directly the logic instead of me thinking now. Yeah. So basically, what's happening? I don't know what's happening with my. Actually, this is my first time using this GoLab because my IntelliJ was screwed in the workshop. So I was like, okay, let me. But now it seems I'm not any better here. Huh. Okay, this is really weird. Okay, so we'll do here an http.serve. So of course, we need to export like a listener to listen for one which will listen on this HTTP server. So to do that, we need to define a weaver.listener, which is basically a wrapper around the net.listener, except that we do some instrumentation around it, but it's nothing else. Okay, so how I'm going to write this logic without copying now? I really don't know here. Let's see. Okay, one I did. I really don't understand what's happening here.
Maybe if you search quick actions for something like clone carrot or carrot.
On GoLand?
Sorry?
What did you say?
If you search quick actions in GoLab.
Quick actions?
Yeah, shift or command shift A.
I think when you right click, it says column mode, something like that. Maybe that.
This one?
Yeah.
Oh. Yeah, I know. I just installed it last night, and now seems I'm biting myself. Okay. Thank you so much. I hope this will. Yes. Okay. Great. Okay. So again, basically, yeah. So now we take the query from this, passed by our URL, and we call the reverse method, and then we write the result back. And let me fix this. And yeah, so now we have an HTTP server. And now if I do again, let me add Weaver generate because I added the listener. And I do go run. Oh, okay, but I don't see where it's running. So let me add a message. And this is a good time to see that every component has a logger. So if I do here, okay, internet. Okay, my internet now is. Okay. Let's print the address where you want to listen. Reverser available at, and we have to write like tuples to the same format as for slog. Okay, so now if we do go run, we should have our reverser at this address 45, and now we can call it 45463. And of course, I have to pass on my reverse endpoint. And yeah, it reverses a string. Let's make it a little bit more nicer. And then maybe we can also have a simple UI. And I'll just have this simple UI, which is basically just a bunch of HTML and JavaScript, nothing Weaver specific. But enough to yeah, and here on the main, when we export the slash, what to do? Yeah, we basically have to, everything which comes on slash, we direct it to this index.html, which has to be an embedding. I mean, again, this is not something Weaver specific. We just, go a little bit through the flow of how you would write a simple semi-realistic applications. And, we have to add this Go embedding to store the result, the content of that index.html into this variable. Awesome. And now, yeah, again, if you do go run, I can go to localhost 3434351, and I can type here. Okay, so, simple application with an HTTP server, a reverser component. Yeah, let's look a little bit, and if you don't believe me that actually, the main component and, okay, I don't know why there are two here. Did I started two?
Yeah, I used
I did, okay. Okay, let me not do this, so it's confusing. So here, you see that when I run this application, I have these two components, main and reverser, and they have only one PID. So basically, they're running in the same process. One annoying thing for me here is like the port always changes for the listener. So let's fix it. Let's specify the address where we want to listen. And to do that, we have now we have to start to write a small config. And here we'll write a simple toml config for our application, where we will add, okay, let me just copy paste. We'll have to add the name of the binary. And also for our listener, let's say if you run single or multi, you want to specify like the address where it's listening. Let's say you want to listen on port 9000. And now, in order to make this config available to the listener, we'll have to add the same name in the code. So in this case, I have to go back to my my listener, and basically give him a name here. So then when the Weaver runs this application, it looks in the config, and for the listener reverser, the name reverser, it will run your application. What did I do? Oh. I guess I didn't copy everything. Okay, so now if I rerun this application, if I do go, oh, yeah, I changed the listener, so I have to rerun this. No, sorry, I have to, yeah. Because I passed a simple config now, so I have to run instead of go run. Okay, so I can specify, I can run it as environmental variable like this. Weaver go run. So now my application will always listen on port 9000. Now I run it in a single process. I also want to run it in multiple processes. So to do that, I will do Weaver multi-deploy, weaver.toml, demo reverser. Oh, yeah, I have to build the binary. Doesn't exist. Oh, because it's demo. So that's when you copy paste without thinking. Right. So now if I do Weaver multi-deploy, same application runs the multi-deployer. By default, the multi-deployer creates two replicas of every component. And if you don't believe me, we can do Weaver multi-status. And we see here now we have two components. Each of them have a different PID. Okay? So now let's add some telemetry data as well here. So we added some logging message. Let's add a metric as well. For example, we want to count num strings to reverse, matrix dot new counter, num strings reverse, and then some help message to be decided. And then to use this metric, I just have to do, whenever I get a request for a string, I just I can increment it or add a delta, and that's it. That's how I add metrics. And if I also want to enable tracing, I have to wrap this HTTP handle func into a Weaver instrument handle func. So basically, I have to do, let's say we want to instrument both the slash and the reverse. We will do weaver.instrument handler func, and let's say root, and then what's happening here? And then we do the same thing for the reverser. No. Reverser. And then I have to define my own mux, custom mux. I can't export on the default one, so we'll do like, again, this is serve mux. So we can have our own custom mux where we instrument the data. So this is var, and then we'll do here. And that's it. So we added the custom mux, and then basically by adding this weaver.instrument handler func around your handle func on HTTP server, we basically instrument the code. So now we will basically generate all the telemetry data, and we will export it for you. So that's it. And now let's say 2 more minutes. If you want to take this application now and run it in the cloud without any changes, actually let me rebuild it with all the changes I did, or let me do this. You will, let's say if you want to run the Kubernetes deployer, you will have to write a small config, YAML config. I mean, initially we had like a toml config, but then because we started to add these Kubernetes knobs people want, but here we just have to specify the app config. In this case, weaver.toml, and the repository. Let's say this is going to my Docker Hub repository. And then for our listeners, the reverser one, I want to make it public, so it's accessible anywhere. So these are the settings for my kube deployer. And of course, as I said, you can add scaling spec, resource spec, and probes and volumes and whatever. But then with this simple config, now if I do weaver kube deploy kube YAML, we are basically building the Docker image around your application. We push it to Docker Hub in this case, and then we generate all the manifest files on Kubernetes for you. And we generate this, OK, so to show you, I have 3 nodes already started. I have a cluster of 3 nodes in GKE. And then I can take and I just deploy it. And again, here I deploy it with kubectl, but then you can deploy it with anything else, your pipeline. I mean, we have example of GitHub Actions and also Argo CD on our website. So now we deploy this, and let's look a little bit what do we deploy, what do we generate for you. Yeah, we basically generate, you see here for the application, we have these components, reverser and main. And then we generate a deployment, a horizontal pod autoscaler, a service, and then some roles and role bindings to configure some permissions. And you can inspect if you want this file. You can manually edit it, or you can configure it in our knobs. But now if I go to, let's assume, yeah, this IP will come. So this is how you run your application in Kubernetes. But then if, let's say, you want, I'm not going to run it anymore because I'm out of time, but I'll just show you this when it works. But let's say now, OK, so now if I go to this IP address, same application, which I run locally, now should be available here. And just works. Now, the last thing I want to mention here is like if you want to export telemetry data to your favorite thing, then you can use our Kubernetes tool to write plugins on how you want to export data. And I'll just show you just the code here. We have a simple example. You basically have to write this main where you run the tool.run, and you have to specify implementation, how to handle the trace spans, how to handle the metrics, and how to handle the logs. In this example, for this telemetry, we export the traces to Jaeger and the metrics to Prometheus. And basically, this is the only thing you have to write. Basically, which endpoint is your Jaeger service listening to, and then you decide you want to export there. And the same is kind of for Prometheus. And of course, you can write your own plugins for other custom things. I'm not going to show that because I'm out of time. But that's a quick overview of some experience to Service Viewer. And to conclude, maybe I should go here. To conclude, yeah, Service Viewer is a framework for writing better microservice-based applications. We don't argue, so don't understand me wrong. We don't argue that you should put everything in a single binary. So for example, if you have multiple teams, you definitely want at least one binary, for every team. Or if you have different languages, we need that. But we are saying like, start with the Weaver approach. If you don't know, write a single binary, and then you start to split into microservices once you are sure of, what you want to do and how you want to split. We realize, like, teams have, even in Google, like 7, 10, 20 microservices per team. And if you talk with them, no one really knows why they have so many. And we are arguing that instead of 7, 10, maybe you need only 1 or 2. And that's the goal of Service Viewer. And by writing the application in this way, the experience of developing, deploying should be much better, and to monitor your application. And also, I don't know how many people care in this case, but it really improves your performance and reduces the cloud cost a lot. So our website is here. We would love to try it out, contribute, give us feedback, and work together to make it better. Thank you.
Thank you. Thank you, Robert. So let's see. OK, we still have 12 minutes before our coffee break. Yeah, let's start with the questions. I see many. I start from here, and then I come back.
Could you please elaborate to what is the main contributor for the superiority of Service Weaver over microservices in terms of CPU? As you showed the slide where there was a comparison. And in terms of CPU usage, Service Weaver was much better. So what's the main reason behind that, the main driver?
One of the reasons is our efficient transport protocol with custom efficient serialization. I think that's a huge one. We don't use gRPC across our internal communication, so we use the internal one. So that, in our benchmark, I think that's one of the main gain. The other one is we have this collocation feature where you can decide how to collocate your components together, so you bypass the network if they are collocated services.
Yeah, exactly. But it's a network. I would expect that it won't affect the CPU usage. It might affect
CPU
latency.
usage is in terms of how many VMs. So because we can basically pack more, requests. We can handle more requests on a single machine. We use less VMs, less instances, and that translates into less CPU cost.
Thank you.
Sure.
Okay. Yeah.
So thanks for your talk. It was really nice. But I would be interested. So how would be the concrete process if now you say it gets large and you want to split it to another team and you want to version it differently? How do you do that? That you have your service viewer component and then you have a separate repository, separate versioning, and so on.
Yeah. So at that point, you have to treat Service Viewer as a microservice itself, and you have to deal with versioning yourself. We don't do anything special if you have already 2 binaries.
So then you cannot you have to define new interfaces then.
The what?
You cannot use the interfaces you defined before and just use them across repositories.
Yeah, but so the problem is when you interact with a Service Viewer application, you have a single point, like the main, where you, let's say, export your listeners. And all the other components and interfaces, they are internal to that particular instance of your application. So when you roll out a new version of the application, all of this, like a new tree of your application will be launched, but all the changes inside will be internal to that application. So those interfaces you can change as much as you want.
So and also, and you have like, when you can break the interface, it means you cannot do rolling updates with that. So because if like so you have like multiple pods and all these service viewer components, and if one of them is already in a new version, they will not work with the old versions of the app that are still there in your cluster?
So if you, you are talking about rolling out a new version of the,
like
so
zero downtime deployments.
Yeah, so one fundamental assumption about Weaver is like all the components within an application version, run at the same version basically. So when you roll out a new version of the application, you have to roll out all these instances. And then you have to do basically blue-green like deployments where the traffic slowly shifts from the old version to the new version. So you basically shrink the old tree and you grow a new tree of the entire apps.
Thanks.
Sure.
That also answered my question.
Any other question? I go to the front so that I can see you. Yeah.
So, and when you promote it internally, for example, to other teams at Google, what is the main argument? What is the main thing that they don't like about Service Weaver that you have to sort of counter-argument? Or
that they don't like about Service Weaver?
Yeah.
I think in Google, things are a little bit more challenging because I think like in general, we have, like people are encouraged to split as much as they can. And then people are not willing to change things easily. And we are not arguing that Service Viewer should be something you should go and change your application now. You shouldn't. But we are saying when you start to write a new service, then maybe you should write Service Viewer to start writing it, and then slowly evolve it. To answer your question, I don't know in Google. Like we have a few teams using Service Viewer, and their main problem was, again, the complexity. Like they end up like 20, 30 microservices. And all this management and complexity was just mind-blowing. And one of the main things was tracing, like how you do like all this tracing across all these distributed microservices. But I think most of the use cases in Google we got like adoption is new applications, like people who wrote new applications, not existing ones. Yeah, new existing ones, I think it's more challenging. And maybe you don't want to do that, yeah.
Okay, thank you.
So in the demo, you have shown that you can just start 2 instances of your process. And my experience is that that's where it gets tricky, because then you cannot have a state, or you have to distribute your state somehow. And I would just want to know if you have like, there's something built into Service Weaver to make that easier, to have like a state, because then maybe your state needs to be external also.
So you are saying how to maintain some state if you have more than one replica. Yeah, so by default, we don't handle that part, but we have this like sharding support, where we basically, given multiple replicas, we can generate this like traffic assignments to basically create like affinity to some of this replica for some of the data. So for example, if you have a cache, the get, I think I show in the workshop, but we can affinitize the key get, the put and the get for the same key to go to the same set of replicas. So that way, you can build stateful applications.
And this would even work with scaling. So if you scale up from
yes, it works. Yeah, because you monitor the health, you monitor the load. Like we monitor the load. You can put your custom load metric as well, and we will have all these fancy algorithms to load balance the traffic across all the replicas.
Is this like consumer groups in Kafka? If you know that, like.
I'm not very familiar.
Okay, thanks.
Sure.
Okay. Do we have any other question? Still have a few more minutes before the coffee break. Yes.
I was wondering, does the transport layer has any limitations, like, I don't know, message size or something like that?
No, it doesn't have.
And I believe it doesn't handle any, retries if it fails.
It has retries. It has retries, yeah.
And can you configure that customly, or it's like?
Yeah, I think that's some part which we are still like thinking. What is the right way? How much we should expose to the user or not? Yeah, we expose errors, and even like environment failures to the user in the code, and you can identify them, and you do your own retries. And also we do retries automatically for you. I forgot like at what level we do though.
Okay.
But we do, I think we do some retries automatically for you. No, you have an option to specify for every method whether it has to be retriable or not. For the retriable ones, I think we try a few times and then we will send it to you back. And the non-retriable ones, you know, we'll just send the error to you directly and you do deal with it.
Okay, and maybe I missed that part. I was wondering, you mentioned that you serialize the data you send. Is it like the human readable format, or is it some custom, I don't know, schema?
It's nothing fancy, basically. The main assumption is because we know the types of the data, the sender and the receiver, because they all run at the same version. We just, you know, take all these bytes and put them in a slice, and you know, yeah, like binary encoding, basically.
Oh, okay.
So nothing fancy.
Okay. Any other question, or we are good? By the way, yeah, okay, you go.
Yeah, so returning to the CPU usage question, actually, wouldn't it be interesting also to compare the performance to a monolithic flavor of the application? How would you estimate how much faster would it be compared to
the monolithic application? I don't know. Yeah, I still assume it will be faster because we have all this, like, as I said, like custom load balancing, you know, and routing based on automation. We have custom resource management as well, but I'm not sure. Yeah, we don't. Actually, no, we had numbers. Yeah, we had numbers. So the numbers I'm showing you here, they are, I don't have it in this slide anymore, but yeah, we actually tested where we put all these microservices in a monolith, even with that version, and we are still like a few times faster. I think the custom transport, like all this, like no versioning overheads, plays a big role. I think gRPC is very slow, yeah, I think the load balancing and the serialization also helps even the monolith.
Okay,
yeah, I don't have the numbers here, but I can show you if you want. I'll dig them up and after that.
Okay, thank you.
Sure.
All right, okay, so let's go.
Okay.
Yeah, oh, sorry.
You can ask me after that. Okay.
Oh, yeah. Yeah, of course, you'll be available, I guess,
Yeah.
throughout the whole day. Yeah. Okay, so I'll let you go have your coffee break, and I'll see you at 11. Enjoy your coffee, and see you all later. Thank you, Robert.
Okay.